Good morning, everyone. Welcome to our video presentation for the Production Control course. We are Group 5, and today we will be discussing key aspects of production control based on the academic reading provided. My name is Juan Camilo Correa, and with me today are my teammates Carlos Vargas, Frei Aldana, Haider Villalba, and Sebastián Moscote. We will each answer to open questions from the reading, focusing on the evolution of production control, its impact on sustainability, human factors, and the role of emerging technologies. Let's begin. We have some different questions, and today we are going to answer and responding some questions provided in the text. So we have the first question: how has the evolution from traditional production control methods to Industry 4.0 changed the role of managers in manufacturing? So the evolution from traditional methods to Industry 4.0 has fundamentally transformed the role of managers. In the past, managers were primarily supervisors who focus on manual monitoring, scheduling, and problem solving based on historical data. For example, in the Toyota production system, control was based on visual tools like Kanban and human lead quality circles. But with the Industry 4.0, technologies like IoT, AI, and big data have automated many of these tasks. So, the managers now act as data interpreters and strategic decision makers. They use real-time dashboards and predictive analytics to anticipate the problems before they occur. For instance, at Siemens Amber plant, AI algorithms adjust machine parameters automatically, so managers focus on optimizing overall system performance rather than micromanaging. This shift requires new skills. Managers must understand digital tools, data analysis, and change management. They are not just overseers, they are innovators and facilitators of technology adoption. And now, we are responding to the question number 16. How can human-machine collaboration, cobots, AI assistants, redefine the traditional concept of production control? Human-machine collaboration is redefining production control by making it more flexible, efficient, and safe. Traditional control often separates human labor from automated systems, but now cobots, collaborative robots, work alongside operators. For example, at Amazon Robotics, mobile robots bring shelves to human workers, reducing walking time and errors. The integration allows control systems to dynamically adjust to real-time demand. AI assistants can also recommend adjustments based on data patterns, something humans might miss in the plant. This doesn't replace the people, it elevates their role. Workers move from repetitive tasks to supervision, problem solving, and continuous improvement. In this new model, production control becomes a partnership between human intuition and machine precision.
How those workforce motivation and tendencies directly influence production control outcomes, and what policies would you recommend to address abastecing? Workforce motivation and tendencies are critical to production control because they directly affect the productivity, quality, and schedule adherence. For example, in the case of General Motors, high abastecing led to an attendance index of only 88%, causing linear stoppage and annual loss of 200 million. To address, I recommend a combination of incentive programs and super policies, GM for incentive in production, and the bonus and flexing sheet. We retain attendance index 96%. Additionally, companies show index in occupational health programs, skill training, and clients party packs with employee feel valued, and they are combined with reduce turn and improve or system reality. In what ways can predictive maintenance reduce costs, and improve production flow in capital-intensive industries. Predicting maintenance outlook sensor and data analytics to monitor equipment's condition in real time, allowing repairs before failures occur. This specialty important in capital-intensive industries like cement or energy, where open late show pays are extremely costly. For example, and Cementos Argos in Colombia, Hills failed caused daily slow and 2000 and implemented pretty maintenance on show base fell 14% and capacity utilization 70% to age 70%. This not only reduces repair costs on also production flow via missing pulse came as result company and maintain step up me delivery and expect the lifespan of machines.
Good morning. Question number 11. What role does production control play in advancing sustainability goals, such as reducing carbon emission and waste? Production control is essential for sustainability because it allows companies to monitor and optimize resource use in real time. For example, Unilever implemented an integrated environment control system that tracked water and energy consumption. As a result, they reduced water waste per ton by 44% and CO2 emission by 65% by 2020. And similarly, Bavaria in Colombia used an automatic system to cut water consumption by 12% and energy use by 15%. The example in short-term production control is who's about efficiency. It's about aligning an operational process with environment goals. By minimizing waste and emission, companies can meet regulatory requirements and improve their public image. And question number 15. We is important to integrative environment metrics, energy, CO2, waste into production control system. And integrating environmental metrics in production control is crucial because its sustainability is now a competitive and regulatory requirement. And companies that ignore these metrics risk fines, reputational damage, and lose market share. For instance, the European Union has strict carbon footprint regulation for import. Companies like BMW and Unilever have shown that tracking CO2 and waste leads to both ecological and economic benefits. When environment metrics are part of daily control, managers can make informed decisions that balance productivity with planetary health. This integration support long viability and aligns with global sustainability standards.
Question 70. What potential ethical concerns arise from using artificial intelligence to make autonomous decisions in the production control? The use of AI in the production control raises several ethical concerns. First, is the use of transparency of called the black box problem, where even engines can fully explain of IA research and decision. This can lead to accountability gaps, especially on the faulty decision cause accidents or financial loss. Second, our systems might derive from historical data leading for unfair treatment of workers or suppliers. Finally, our brains or I could reduce human oversight and the critical thinking companies must ensure that AI systems are authentic, fair, and used to support, not replace, human government. Question 20. If you were the production manager in the global company, what three priorities will you set and balance productivity, competition, and the sustainability and why? If I were a production manager in global company, my three priorities will be: first, implement real-time monitoring systems using uh, IT and IA. This would improve productivity by identifying bottlenecks and reducing downtime and shield and the CMILs and GUI case. Second, invest in the workforce training and the well-being, motivate and skilled employers are essential for maintaining quality and innovation. There's integrated environmental metrics into their control. This ensures we meet sustainably targets while counting costs, like unlevel and Bavaria diet. Toward these priorities, creative balance systems that is efficient, company, and responsible.
Is one wide scan controller in production control affect customer satisfaction and market competitiveness? Failure in production company can severely impact both consumer satisfaction and market. Competitiveness, for example, if a company fails to meet the deadlines like Volkswagen did before implementing meets customer, might lose trust and turn to competition in the automotive industry. The lights can disrupt entire supply chains and seaweeds are both production in Swiss quality control. Failures also directly affect customer satisfaction. Samsung egg defect rates in microchips not only caused financial loss but also damages their reputation in the high competitive market. In today's globalization, economy, consistent quality and on-time delivery are baseline expectation. Companies can file the control tests aspect risk losing market chart to more reliable competition. What are the main challenges for SMEs in implementing advanced production control system and how can they overcome them? Small and medium-sized enterprises face several challenges in adopting advanced production control system. The main barriers include high costs of technology, lack of technical expertise, unlimited scalability. According to the reading, more than of industrial estimates in Latin American struggle, which tends in sus. However, there are ways to overcome these challenges. Estimates can start with process implementation. For example, adopting code-based ERP system instead of expensive on-premise solution. They can also partner with universities and government programs for training and funding. Lead manufacturing principles and see in Toyota's case of their low cuts strategies for improving control with two massive investment by focusing on continuous and gradually integrating digital tools. Estimates can chance their production control will managing resolutions with
Hi again. In conclusion, production control has evolved from manual oversight to a strategic, technology-driven function that imparts productivity, competitiveness, and sustainability. From my insights on Industry 4.0 and to Sebastian's ethical reflections on AI, we've seen how vital it's to adapt to new tools while keeping human and environmental values at the center. Thank you for watching our video. We hope this presentation has provided a clear and critical perspective on modern production control. Have a great day. Thank you so much.